Okay, here we go. Problem 4-102. On separate pairs of axes, sketch the graph of each equation or inequality below. Letter A. Y plus 5 equals the quantity of x minus 2 squared. Oh, this one looks fun. Let's get started. In order to graph this, I should put this into graphing form. I know that if I isolate my y, I should have y is equal to the quantity of x minus 2 squared minus 5. My locator point is the point hk. For a parabola, we know this is the vertex. So this would be the point 2, -5. All right, let's take it and let's plot that point. So I'm going to go to the point 2, and then I'm going to go down 1, 2, 3, 4, 5. Oh, that's nice. Now, let's come up with the rest of our points. Remember, we're just transforming our parent function. This one is not wider or narrow, so it's the same as y equals x squared. So as we move to the right one, we're going to go up 1. And remember, we have our line of symmetry that would run directly down the middle right through our vertex. So we're going to have the reflected point on this side. Then if we go over 2, we'll go up 4. So over 2, 1, 2, 3, 4. Yay, that's very nice. Now let's go ahead and reflect it. And let's go ahead and let's do 1 or 2 more, because it's just asking us to sketch the graph. So if we go over 1, 2, 3, 3 squared is 9. So we go up 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we just want to reflect it over. So 1, 2, 3. There we go. Very good. Let's take it now and let's sketch it. Hopefully you're able to sketch it a little bit neater than I am, but I'm using a program that's hard to draw with. That's okay though. I'll just do my best. And we've sketched our parabola. All right, that was fun. Let's move on to letter B. For letter B, we have y is less than or equal to the quantity of x plus 3 to the third power. Oh, that's great. This one's cubic. So we're going to follow the same rules there with our locator point. Remember, our locator point is the point hk. Well, nothing's being added, so k has to be 0. So we're going to end up with our locator point as the point -3, 0. Ooh, that looks tough. So if I take it here, because it's an inequality, I'm still going to graph my function first, and then we'll look at the shading part. That'll be interesting. So let's move our locator point from 0, 0 over to -3, 0. So we should have a point about right there. And as we graph the rest of it here, remember, our cubic function looks like this. As we go over 1, we're going to cube that. 1 cubed is 1, so we'll go up 1. As we go over 2, we would cube that. 2 cubed is 8, so we're going to go up 1, 2, 3, 4, 5, 6, 7, 8. And the same thing the other way. If I go back -1, -1 cubed is -1, so I'm going to go down 1. And if I go back 2 to the left, that's like -2. -2 cubed is -8, so I'm going to go down 1, 2, 3, 4, 5, 6, 7, 8. Ooh, look at that. That looks nice. So let's take it here and let's go ahead and connect our points. So we're going to have our little cubic function. Ooh, that one was close there. That's a little off, but I'm doing my best. Hopefully you are too. And then it's going to curve upward. like this. Not too bad. Now, because we're looking at all the values of our y's that are less than or equal to this expression here, or these the outputs from this side, we're going to be looking to shade beneath our line. So if you just put your pencil on your graph and then you just move it downward, that would be the correct side. So let's just shade it in here. I'm going to shade using a crayon. Crayons are fun. Do you like crayons? Ooh, green. This will be nice. So let's shade in our green. And everything beneath on this side here would be a solution to our inequality. Well, let's just check it just to be sure. So let's go back here to our pen tool. And we were using blue, so let's go back to blue. I'm going to check using the 0.00 because it's one of my favorites. Let's plug it in. So we're going to check by plugging in the 0.00. So 0 is less than or equal to 0 plus 3 to the third power. 0 plus 3 is 3, and raised to the third power is 27. So 0 is less than or equal to 27. That is a true statement. We are correct. Great job, everybody. Now let's go on to letter C. This is our last one. All right. So we have y is equal to 4 plus 1 over the quantity of x minus 3. It's been a while since we've graphed a hyperbola, so let's just think about that for a second. We said our general formula was y is equal to 1 over, we had our x minus our h, and then we had plus k. We don't have to worry about a here because there's nothing being multiplied, or we have nothing in the numerator here. So our locator point is going to be the point 3, 4. So we have the point 3, 4. And remember, for hyperbola, our locator point is where our asymptotes. Ooh, I almost said a bad word there. Asymptotes. That's going to be where they meet. So let's take it and let's draw in our two asymptotes. It is kind of a fun word to say, though. Let's draw them in here. And remember, they're dashed because our graph will never, ever reach those lines. Ooh, oh, this one, I'm doing a good job. I am pretty straight. So we have a vertical asymptote where y is equal to, where x is equal to 3. And now we need to do our horizontal where y is equal to 4. So let's put that one on there. That's very good there. So your asymptotes should look like mine. Now, we need to make the actual graph of the points that would work here. Now, normally, since our a value would have been 1, we're probably going to have a point that's probably 1 away from our locator point and 1 up here. So we're going to put, let's graph it in blue. Let's put a point right there. And then we probably would have a reflection there. Now, to come up with that value, we could say, oh, let's plug in 4. If x was 4, we have 1 divided by 4 minus 3 would be 1 over 1. We have the point 4 plus 1, so 4, 5. So I went over 4, and I went up 1, 2, 3, 4, 5. Oh, that's awesome. Let's take it here. We know it's going to get closer and closer to our asymptote, so let's just try to draw it in here. So it's right along the asymptote. It's going to curve, and then it's going to kind of go along our other asymptote, getting closer and closer, but never actually touching it. Oh, that looks great. Let's do the other part of our graph here, of our hyperbola. And remember, it's not hyperbola, it's hyperbola. So here we go. We're going to be closer, and it's going to come here. Remember, we're just sketching it, so it's not going to be perfect. Nobody's perfect. We just do our best. Ooh, I missed, but that's okay. It happens. And I'm going to go down, and I'm going to try to get myself closer and closer and closer. Oh, this one's not very pretty, but not everyone is, and not every graph is going to be the best. So I tried, but it should look something like this if you're sketching it. Now, does it ask us to do anything else? I don't think so. So it says 4-102, we've sketched each of our different graphs here. We have a parabola, we have a cubic function, and we have a hyperbola. This is problem 4-102. I hope this helped you out. If not, please make sure that you take the time to ask your teacher. Okay, thanks for listening. Hugs and kisses, everybody. Bye-bye.